Afternoon and welcome to the third session. Actually, today it is supposed to be raster data processing using Python, but actually in the last lecture I could not cover a basic library called NumPy and Matplotlib. So before going to the raster data processing, I will just introduce you to the basics of NumPy and Matplotlib, which we'll be using extensively in the raster data processing. So before going to the raster data processing, it is mandatory that you get yourself familiar with the library called NumPy. So the contents of this particular session has been taken from the NumPy Illustrated, the visual guide to NumPy. The link I have shared here. Actually, you can search this on the internet. Also, the heavily the contents have been taken from this particular link. So NumPy, NumPy or numerical Python is an open source Python library that is used almost in every field of science and engineering that you are doing with Python programming, right? So almost if you are going to solve any kind of computational problem where matrices or numbers are involved, that then NumPy is the core library for all these functions. It's the universal standard for, you can say that, for working with numerical data in Python, and it is the core of scientific Python and all PyData ecosystem. So entire scientific Python ecosystem revolves around NumPy library. So if you want to excel in any of these fields, then you must get yourself acquainted with the NumPy. The NumPy API is used extensively in Pandas, SciPy, Matplotlib, scikit-learn, scikit-image, or even other data science packages. Plus, like all deep learning packages like NumPy arrays, they have similar concepts of tensors as NumPy arrays. Plus, NumPy array contains multi-dimensional array and matrix data structures. It provides ND array. So the base class in NumPy is ND array. So it's an homogeneous n-dimensional array object. So all the elements of your NumPy array must be of similar type, maybe integer, float, or string types, whatever you want to, with methods to efficiently operate on it. So basically, it is for numerical data computations. So plus it has, like, all the data can be stored in arrays, and there are different methods to efficiently operate on these data. NumPy can be used to perform a wide variety of mathematical operations on arrays. So whatever operations you will be doing in your linear algebra, so this all these operations you can do on the NumPy arrays or matrices. Right, so like this, you can see that these are some examples. Here we have a vector, or you can say one-dimensional array or a vector. So with two elements, if we add, suppose if you want to add 3 to every element of that array, you can just say this array plus 3. Then this 3 gets added to every element of this array. Like similar way, subtraction, multiplication, division, or integer division, depending on whatever operations you want to do. Then there is an special operator that actually I think I missed yesterday. So in Python, this double star is an exponentiation operation. So like 3 raised to the power, like this is the power function. So we can say that if you want to compute 3 raised to the power 2, then you can write 3 double star 2. So you can calculate the raised to the power. So basic thing, suppose if you are going to if you are using your own local installation of Python, then before starting, as I explained, that by default all libraries doesn't come, so you need to install this specific library. So for that, if you are using Anaconda, you can just call conda install numpy, or even using pip also you can install numpy to your local installation, like pip install numpy or conda install numpy. So now first, once a package is installed, now we need to import it for using its functions, right? So for importing numpy, we will calling either you can write numpy. So when you write it, let's import numpy as np. So whenever you, if you want to access any function inside numpy, then now you can refer numpy as numpy. So np, sorry. So it means like we are giving a shorthand, like shorthand for numpy, like by as np we are getting a shorthand for numpy. So this saves us from typing. So all the time we need not type numpy. So we can refer numpy package just as np. So this, you can say that this is an alias for numpy. So first thing you need to, this is a standard convention. You can alias it to anything but it is generally whenever you will see numpy is being imported, though, so all will be calling is at np. So this is np is an alias or shorthand for np that saves us from typing. Right. So, what is an array? If we talk about going before that, what is an array? So, an array is the central data structure of a NumPy library. So, basic data structure of the NumPy is ND array or an array. So, array, as you if you have you use programming, so array is a grid of values, right? A grid of values. An array can be indexed by a tuple of integers, or maybe by booleans or another array or integers. So once you have an array, suppose if you want to access any element of that array, like we discussed yesterday about strings or lists, for accessing any individual element of that array, we need indexes. So depending on how many dimensions are on our array, so many indexes we need to access an element. Like if we have just one dimensional array, then we need just a single index to access the element of an array. Now if our array is two dimensional, or it is a grid of cells, so in that case, suppose we have arranged our data in rows and columns, then we need two indexes to access any element of the array, like a row number and column number. Right. So the rank of rank of array is called number of dimensions of an array is in NumPy's terminology, or in NumPy parlance, we can say that the rank of array is the number of dimensions it has. Actually, in matrix, the rank is a different thing, but in in the context of NumPy, we call the rank of array, whatever number of dimension it has, that we call the rank. Like if we have one dimensional array, we can say that this is a one rank array. If it's a two dimensional array or matrix, we say it this is a two rank matrix. And the shape of array is the tuple of integers giving size along each dimension. Like if we have a two dimensional array, then we can say the shape of an array is, like suppose there are two rows and three columns, we will say the shape of an array is 2 comma 3. So number of a tuple in which every element of the tuple is number of dimensions in the particular in each dimension. So first thing is vector or one dimensional array. So these are two things. So vector and one dimensional array are the same thing. So let's see how do we create an one dimensional array. One dimensional array is very similar to our list. So what is the difference between the list and a NumPy array or a matrix? Like basically lists are quite general in nature. They have been designed to contain different types of elements, maybe because they are quite general in nature. Because of that, they are not so much memory efficient. But NumPy arrays are specifically designed for handling numerical data. So they have been optimized for handling numerical data. So that makes the difference. NumPy arrays are, because Python lists are quite generic in nature. Because of the generalization, their implementation is a bit different from the implementation of NumPy arrays. NumPy arrays are specifically designed for numerical numerical operations on numbers. So because of that, they are quite fast and compact in comparison to the Python lists. So like suppose if you want to create a one dimensional array, so in a NumPy package there is a function called np.array. To that you can pass the list of values or elements, right? So this creates an one dimensional array, because now there is only single, maybe a single list, like all the elements in a single row or maybe a single column. Actually we will not say row or column. Actually there is a difference between a two dimensional array with you can say the row vector or column vector. So this is just similar to a list, right? So how do we create? A equal to, suppose if I am creating np.array, and inside the array function I can pass a list of values 1, 2 and 3, right? So this creates an NumPy array. Now if I just print this A, you can say that array with values 1, 2 and 3. Right, so every element has a data type, like this maybe by default is, because we have given it at 1 dot. 1 dot means 1.0, 2.0, 3.0. This is a type of 64-bit float, and you can see the shape, because this particular array has a single dimension. So its shape, you can see that it is showing a tuple with just a single element, because there is only one dimension. So it shows like there are three elements in the dimension 1, so its the shape is shown as 3 comma a tuple with single element, right? And one more thing you must uh, keep in mind that numpy arrays cannot grow the way Python list does. As you explained that Python arrays are quite generic in nature, they can expand or contract, but numpy arrays has fixed size. Like once you have created a numpy array, you cannot so easily change it, because there are ways to change that, but you cannot change the size of a numpy array. So no space is reserved at the end of array to facilitate quick appends. Actually, appends are possible, but it is difficult. So it is a common practice to either grow a Python list and convert to a numpy array when it is ready to pre-allocate the necessary space. Right. So whenever before creating an array, you must compute its size, like those. So easily you cannot grow or change the size of your numpy array. So it's like, suppose if you don't know initially the values, you just create an array with all zeros, and later on you can change the value. You can change the contents inside the array, but you cannot so easily change the size of an array. So if you want to create, like there are like once we have created one a single one dimension simple one dimensional array. Now suppose if you want to create, sometimes it may be a requirement, like it is often necessary to create an empty array which matches the existing one by shape and elements type. Like suppose if you are copying some image or some other data, and suppose if you want to modify that contents later, right? So suppose if you want to copy some image, so you have to create a new array. Suppose there may be requirement that you want to create an array which has the shape, size, and the data type it contains that are similar to some other array. But suppose if you want to initialize all elements of that to 0, so there is a function called np.zeros underscore like a. So what it does, it creates an array which is similar to a, like in the terms of shape and size and the data type of the elements, but all the values will be 0. Right, so now here if you create an A of type float 62 or 32 bit, then it creates an array with same shape and size and element type as an array A, but all the values of C will have the value 0. All elements of the C will have the value 0. Similar way, all other functions like np.array, there are there is a function for np.zeros, right? Numpy.zeros creates an array of all zeros with shape 3. Then np.ones again pass in an argument like how many elements you want, the shape of an URL, and then empty creates with very low values, and np.full 3 comma 7. So it creates an array with some specified value. Like if you want to create an array of size three elements array with all values of array you want to initialize to 7, then you can call np.full, right? So np.03 creates an array of size 3 with all elements with its all element initialized to value 0. Like np.ones create an array of size 3 and all elements of that will have the value 1. Similar way, np.empty 3 will create an very empty values, or you can say very garbage values which are near to 0. Then np.full 3 comma 7, so it creates an array of shape size 3 with every element of that initialized to value 7. So all these function has a counterpart called like zeros like a. So what it does, np.zeros underscore like a, so it creates a new array which has similar shape and size as array a, but the values of the new array will be initialized to 0. Similar way, np.ones like a, so creates a new array which has same and shape, size, and all elements, data type of all elements to be as of type A, but the values initialized to 1, like full like A. So every of these zeros, ones, empty, full are, there are counterparts like zeros, ones, like, right? So then sometimes the requirement comes when you want to initialize, like till now we have seen that we were just creating, we are assigning them some values like 1, 2, 3 or somewhere maybe some random values. Now suppose if you want to create an array with where you want to initialize its values to a monotonic sequence, like monotonically increasing sequence. So there is a function called, like we have discussed yesterday, range function. So similar to range function, there is a range function in numpy. So like if you call np dot a range, then it accepts this a range function accepts three arguments. So actually only one argument is mandatory. The remaining arguments are optional. So depending on your requirement, you can pass on the values of the remaining arguments. Like if you call np dot a range and if you pass it just a single value, so that will be taken as the value of stop. So what it will do, it will generate the values from 0 to 5, 0, 1, 2, 3, 4, and 5. Here you can see that if you just call np.arange6, it will create an array of 6 elements. The value, say, a one dimensional array of 6 elements, and the value of that will be assigned from 0, 1, 2, 3, 4, 5. Similar way, suppose if you pass two arguments to the arange function, like two arguments will be taken as start and stop. So it will start from 2 and go up to 5. 2, 3, 4, 5, a 4 element one dimensional array. Then if you pass third argument also to this, so this will be taken as the step increment. Like if you pass 1 to 6, so first value will be 1, then the value will be incremented by this step size 3, 1 plus 2, 3, then 3 plus 2, 5. So this way you can use this a range function. Like if I call this np.arange6 with the single argument, you can say that it created an array with values 0, 1, 2, 3, 4, 5. If I call arange2.6, 2, 3, 4, 5, arange 1, 6, 2, 1, 3, and 5. Right. So then actually there is, once an array is created, suppose if you want to change the shape of an array, like because this is till now whatever we have seen is an one dimensional array. Anyway, actually when it comes later, when you see two dimensional, then it will be more clear. So, so here with a np dot a range, I am creating an array with a one dimensional array with 12 values. Suppose if you want to convert it to a two dimensional array, suppose that if you want to rearrange them into certain numbers of rows and columns. Now this contains a single row. Now suppose if you want to rearrange them in maybe say three columns, 3 rows and 4 columns, then we can call, there is a function called np dot reshape, or actually directly on the array class also you can call this function. Otherwise from the numpy package directly you can call np dot reshape, and here you pass then your array, and the second argument to that function should be the reshape. Like shape we said like 3 rows and 4 columns. So you can say that this got rearranged into, but now actually you can change the order also, like if you want to make them in a row measure order or column measure order. Now here you can see that this is made using row measure order. Right, now as we have seen in the list, similar way, suppose if you want to do indexing, like once an array is created, it is natural that you will need to access the values in that array. So now the question comes, how do we index that array? Like how do we fetch some single value or maybe a set of values from that array whatever we have created? So once data is in the array, NumPy is brilliant at providing easy ways of giving it back. Like once you have created an array, now NumPy gives us a lot of options for, or a lot of options for how do we fetch the data back from that NumPy array. There are many ways for doing that. So as we discussed yesterday, similar indexes exist for NumPy arrays as well. Like, right, so every element of the NumPy array starts with the index 0, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, or they might have some negative indices. Like this 5 will have indices of -1, this 4 will have index -2, -3, -4, -5. Right, so the positive indices start from left to right and in the incrementing order 0, 1, 2, 3, 4, and the negative indices start from the last element and increment to the left, -1, -2, -3, -4, and -5. Right, so suppose now if you want to access an individual element, because this till now we have discussed about an one dimensional array. So for accessing any element of that array we need just a single index. Like which particular element you want to access. So if I want to access the anyway, as we have seen that now we are seeing that indexes in computers start with 0. So suppose if you want to access the second element from this vector or one dimensional array, so then you can pass a and its index number, like a1 will fetch us the value 2. Similar to yesterday, now if you want to access some multiple elements together, right? So similar way, a, your name of your array, square brackets, and your starting index, colon, your ending index, like from index 2 to index 4, but 4 will be excluded. So it will fetch us the elements at index number 2 and index number 3. So at index 2 we have the value 3, and index 4 we have the value 4. So it fetches us the value 3 and 4. Now actually after colon the you can the after colon the value is optional, right? So now I can pass it, I can call it like this, or name of my array, square brackets, -2 colon. If the value after the colon is missing, it means, it means that it will go up to the end, right? So where is -2? So this is 5 is -1 and 4 is -2. So -2 to last, so it fetches the values 4 and 5. Then actually you can have a double colon as well, like, so this tells the indices. So any of the value can be missing, like if I write like a double colon 2, so what it goes, like our starting value, we have not passed anything to the starting, so anything is missing, it means it goes from the starting. So it is like from starting to ending and incremented every step by 2. So it goes from 0, then 2, then 5. So it fetches the values 1, 3 and 5. Similarly, now suppose if you want to, so these all were you were picking up elements in certain sequence. Now suppose if you want to pick up elements from the random index, like you want, I want item number 1, item number 6, item number 8, then again item number 0, then item number 5 and item number 3. So suppose if you want to pick up the elements in that sequence, then you can pass the array indexes in the form of another array, right? So if I am passing like a, then double brackets 1, 3 and 4, so what it does, I am able to pick up the elements in some non-contiguous way, right? In these the indexes were in sequential order, maybe like 1, 2, 3, 4, 5, or maybe 1, 3, 5, 7, 9. But in this, I can pick up in any order which I want. So if I pass the to my array indexes in form of another array, then I can pick up the elements in any order. Like this will pick up item number 1, 3, 4, and even I can pass on 5, 6, or even I can go back to 0 and so on. Right, then similar ways, the way you pick up, now you can change the values also, like this indexes can be on the left side also. Now suppose if you want to assign element 2 and 3 0 value, if you want to change their value from their existing value to 0, then you can write it like this also. A square bracket 2 colon 4 equal to 0 will assign the second and third element of the array new value 0, right? So after this the array changes to this. So this way you can use indexes. Then these were the integer indexes. Now NumPy supports a Boolean indexing as well, right? Suppose if you call something like a is our, assume that a is our original array, a with these values. Now if I call a greater than 5, like if I write a greater than 5, so what it does, it creates a new array. The new array will have the same size as my original array a, but the elements of that array will be wherever the value of wherever the value of this element is greater than 5, they will become true, and wherever the value of a is less than 5, all that elements of this new array will become false. Like here you can say this at zeroth element has value 1, so this is less than 5, so it has become false. 2 has become false, then 6, 7, 6, these has become true, and all other values, these values are less than 5, so because of that these have become false. So if I write the statement like a greater than 5, so it creates a new Boolean array. So wherever that condition is true, those all elements will become wherever the value condition is true, those will become true, others will become false. Now I can call like from this array, if I call like np dot any a greater than 5. Now suppose if I want to check in whether if there is any element in my array that has value greater than 5, so then I can call a function called np dot any a greater than 5, it returns true. Now suppose if I want to just fetch all the values which are greater than 5 from my array, so then I can get it like this level a, then inside indices I can pass a greater than 5. So what it does, a greater than 5 will create an array like this, and if I pass it a at this array, so it will just fetches the values where index is true. So like it will fetch the values 6, 7 and 8. Then suppose if I want to check whether all values of my array are greater than 5, so simply I can write np dot all and a greater than 5. So it will check whether all the values inside my array. So actually if you are used to other programming languages, there you need to write the loop like for loop for starting from 0 to maybe the ending point, check all. So but in case of NumPy, you can just do it with a single statement, right? And same thing, like suppose if you want to change all values which are greater than 5 to 0, so it may be like this, may be an application like, so you are reading an image and some pixels maybe like suppose you assume that the values number pixel value above 200 may be a saturated pixel, so all those values, you suppose if you want to replace it with 0, so you can just by a single statement you can write like a greater than 5 equal to 0. If you write all the values where all the elements which has value greater than 5 will be initialized to 0. So now this original array will change to this way. Right, then you can combine multiple conditions with and also, like here we have written a greater than equal to 3 and less than 5 equal to 0. So wherever a is greater than 3 and less than 5, if you want to just make just those all values 0, then you can write like this. So this way you can combine any complex expression you can build based on these things, and or x or not, whatever way you want, you can combine these multiple constructs together to make a complex expression, right? So similar, so now let's see how do we apply some vector operations. Like arithmetic is the place where NumPy speeds science most, right? So vector operators are shifted to C++11 and allows us to avoid the cost of slow Python loops. As we said that Python lists are slower compared to the NumPy arrays, because NumPy arrays are specifically designed for handling numerical values, and as you can read out here, so vector operations are shifted to C++ level. So like these are as fast as the C++ array operations. So NumPy allows to manipulate the all arrays just like an ordinary number. You need not write any loops. So internally, NumPy will take care of all this. So these operations are quite fast and very compact to write. You need not write any loops. Suppose if you want, you have two arrays or two vectors, or two arrays, or say two one-dimensional arrays, two vectors, and you want to add them element wise, like addition of two vectors. So whenever we are adding two vectors, what do? We add the to both vectors element wise, right? So this you can just write plus operator. Like if you have an array A and array B, we just need to write A plus B. We need not loop through all element one by one. We need to just write A plus B. So it adds both the arrays element wise, like similar way subtraction, similar way multiplication, division, integer division, or exponentiation. Anything you can do with it. So all the operations can be. So this is whatever we are covering here. It just a tip of an iceberg. So there are many more things. So whatever operations you need to do on NumPy is matrices. It is available on the NumPy. Actually, there is a very exhaustive documentation or tutorials available from the NumPy's official site as well. You can go through. Once you are familiar with this, you can just go through and explore yourself. There are many more to it. This is about one-dimensional array. Now let's shift our focus to the two-dimensional array. So in the one-dimensional array, we had just a list of values. So two-dimensional array or matrix initialization is similar to that of vectors, but in two-dimensional array, now we will be arranging our data in, say, called rows and columns, right? So now for creating rows and columns, so np.array, there was a single list. Now first we will put, so like you can see that these outer brackets, inside this every row we will separate by a comma. So every row will be inside a set of square brackets. Like this first row in first set of bracket, comma, then second row, comma, maybe third row, comma, fourth row, and so on. So this way we create a two-dimensional array or matrix, right? So here every row will be separated by a comma. So there all elements were in a single list. Now every row is separated by a comma, right? So this way you can see that this we created an array of, if you see this will create an array of this type, like two rows and three columns. The data type anyway by default, because we have given 1 2 3 and it is of 32-bit integer. And now its shape, if you see shape, what we said, that shape is a tuple, a tuple with number of elements in along each axis. Now their row is called the first axis and number of columns is the second axis. So there are two elements in the first axis, first dimension or axis, and three elements in the second dimension or second axis. So if you query the shape of this array, it says 2 comma 3. And similar way, if you want to, like np.zeros function are there. So if you pass its proper dimension, like if you call np.zeros and pass its shape as 3 comma 2, so it will create an matrix of 3 rows and 2 columns, and all the elements of that array will be assigned the value 0. So similar way you can call np.full. First you are specifying the shape of your array and then the values in each element. Similar way np.I, actually there is a function called that creates a diagonal matrix, np.I 3 cross 3. So it is creating a diagonal matrix or identity matrix of 3 cross 3. Similarly, there is a function called np.once. So it creates an array of with values 2. Empty creates an array with empty values, or say very low values. And so similar functions, whatever we have discussed. So all these functions are available. Now indexing. So similar to one-dimensional indexing. Now in case of two-dimensional array, for uniquely picking up an element from our two-dimensional array, now we need two indexes, right? One is the row number and another is the column number. So when we know exactly row number and column number, then only we can pick up the element uniquely from our two-dimensional array. Now suppose if this is a two-dimensional array, and suppose if you want to pick this particular like 7 from the list, right? So first we need to pass it to our indexes. One is a row number. This particular element is existing as like row index 1, because as we said, as indexes start from the 0. Row index as 1 and column is, this is a 0 1 2 and column index is 2. So 1 comma 2 picks up the second. Now suppose if you pass instead of a number to the column, you can specify, if you just specify column, so what it is, it does row number 1 and all columns, right? So instead of just picking the second value, you can pass it like 1 comma column also, so it picks all columns from the row 1. Or similarly we can say specify a column comma 2 all rows from the second column. Right, so this specifies all rows but first and second column. Similar way this way you can make any all rows actually, but increment by 2, then columns also increment by 2 starting from the 1. So this way you can pick up values accordingly, or even you can pass an array as well. So matrix arithmetic are also quite similar to what we have done in one-dimensional arrays. So same thing like plus, minus. Also like you need not run loops, to for loops. You just need to just plus, minus as you are doing for simple ordinary variables. So similar way you need to do for NumPy arrays also. Then suppose if you want to do some basic statistics on that data, then there are function called, like you can call min. So dot min, like your array dot min, if you call it, will calculate the minimum value for your entire array. Now suppose there may be requirement, like instead of calculating the minimum in the entire array, you may be interested in calculating the row wise minimum or maybe column wise minimum, right? So to the min function you can specify an argument called axis. So if you call if you pass an argument at axis equal to 0, it will be calculating what you call, this may be the column wise minimum. Or similarly, if you call axis equal to 1, it will calculate the row wise minimum or maximum, standard deviation. There are many more functions. So this is about two-dimensional array or matrix. So now next, because NumPy, as we said, that NumPy can handle n-dimensional array, because actually visualizing the arrays beyond third dimension becomes very difficult. So till now we have discussed about two-dimensional arrays. Now let's discuss about three-dimensional array. So what is three-dimensional array? Three-dimensional array is like whatever we have discussed in two-dimensional. Now suppose if we stack multiple two-dimensional arrays together, so that is what is called three-dimensional array. Now here we can see that now we have stacked three 2 by 4 arrays together, right? Now for accessing any element on this two-dimensional array, now we need three indices. Like creating a three-dimensional array also is quite similar to creating two-dimensional arrays. Only thing is now we will be creating separating these by two-dimensional arrays first by commas. Like then we need to start it with three square brackets, and inside that we just keep on creating two-dimensional array on the one on the top of another. For accessing these elements, now as you can see that now we need three indices. So first index will tell us, like from that stack pick up which two-dimensional array. Like there are three this is a stack of three two-dimensional arrays, right? So first index we need to pick up which two-dimensional array, like whether this second one or third one. First element this, then from that once we identify that particular two-dimensional array from that stack, then row number and column number in that particular stack, right? So now if you say the shape of this array will be like whatever three. Now we have here three stack of this two-dimensional arrays, then rows and columns. And size of an array is like how many total elements are there in this array. So like there are 3 multiplied by 2, 6, 24. So there are totally 24 elements in this array. So this one-dimensional array is also like NumPy has the function like zeros and ones. They can create one-dimensional, two-dimensional, three-dimensional, four-dimensional, whatever number of dimensions you want can be created with this. So like np dot zeros, you specify its argument. So these three-dimensional, two-dimensional, three-dimensional arrays, like our image, whatever we will be seeing here also can be represented as three-dimensional array, right? Suppose if we have a multiband image, multiband raster image, so that image so every every two-dimensional array in that 3D matrix can represent a band, like this because our image will you must have discussed, actually we have seen in the first lecture that an image is just a cell or grid of is a grid of cells, right? So here every grid may be representing one band. Like suppose if our image has 3 bands, so this is our image will be internally will be represented as a three-dimensional array with maybe with the shape 3 cross then width and height of our image. Like this may be this is a standard representation of our image in matrix form. Like every two-dimensional matrix may represent a particular band of that image, maybe red band, green band or blue band. Now once we know about these basics, now let us see how do we visualize that image. So that will be useful in our further processing. So for that we will be using another library called matplotlib. So matplotlib is the Python plotting library which produces publication quality figures and provides quite easy and intuitive interface for plotting the data. Right. So if you have your local installation of matplotlib, then you can install it using maybe Conda or pip. But in case of Google Colab, it comes pre-installed. You need not do anything. Right. So the basic package for plotting in matplot, because actually we will not discuss about other plotting functions. There are many more features to it. We will just see how do we visualize an image. So actually whenever you read an image in Python using NumPy or any other library, the image data is represented as a three-dimensional depending on number of bands, three-dimensional or two-dimensional NumPy array. So then matplotlib can be used for visualizing that, right? So the core package for image plotting is pyplot. So first we need to import, and this is the standard convention to call the pyplot as PLT. So first thing whenever you are going, you need to call import matplotlib.pyplot as PLT. Then I am importing here another module inside matplotlib, that is called image. So that is actually basically will be used for reading an image. Actually, in when we do raster data processing, we will not be using this MPIMG because this is very, it can read just a very like JPEG and PNG, very basic formats only. It is not very advanced. So we'll be using a different library for reading the data. But as of today, actually, I will just use it for reading a simple PNG image, and we will visualize that particular image only. So I am, because tomorrow onwards, or maybe if time permits, in the last 5 minutes, we will try to see there is another library called JIDAL that we will be using for reading raster data. Anyway, as of now, we'll just use IPIMG because I just want to show it. Here, our focus is mainly on visualization, not on reading an array. So I have just imported two packages, MPIMG and PyPlot. If I run it, and then I will just re-upload the file here because this file may not be existing. Let me upload the file first. So as we said that in Google Colab you can upload your own data as well, because it has given us a virtual machine with maybe some 40 or what around disk which has 20 total disk is, I think it shows around 100 GB, and 26 GB is around 110 GB space it has given. So in that you can upload your data. But what happens if you just upload your data here, once you restart or log out of this, that all data gets lost. So it's better, like suppose if you want to access your data repeatedly, so instead of storing it in the directly in the virtual machine, you can store it in your Google Drive and link that Google Drive to your Google Colab. But right now I'll just upload to my VM only. For uploading a new file to my VM, you need to just click on this folders, and icon comes here to upload to session storage. I will doing here, and I will upload that file. So then it prompts a message like enter the files you are saved. This runtime will be deleted when the runtime is terminated. Like once you terminate this runtime, this file will get deleted from the VM. So it's better either you store it in the Google Drive. Suppose if you are uploading it just one time is good enough. But if you want to access that file multiple times, then it's better to store it in Google Drive and link to the Google Drive. So it takes a while to upload that file. So by the time or I could have uploaded it to the drive. Okay, let me upload it to the Google Drive. So upload on the drive is quite faster. So it got uploaded. So I will stop this, and now because my data now is available at my Google Drive, so I need to first access my Google Drive from the Google Colab. So how do we access the Google Drive from Google Colab? So you need to click on this icon here. So if you click on this icon, it creates a piece of code like from google.colab import drive, then drive.mount, and if you just run this, then it asks for some permission like connect to Google Drive. You need to provide your credentials. Allow. And if you see here, once this, like whenever it is rotating, you can say that this particular cell is executing. So once this is done, then if you just refresh it, you will see a new folder here with name drive. Then inside the drive, my drive, and you will be seeing all your Google Drive, entire all folders of your Google Drive. So here we have tehri.png file. So actually, by default, what happens? This IM read also searches for the file which we are reading in its current working directory only. If you want to access any file that is outside the current directory, then either you change your working directory or copy the path of your file. So copy path and you paste here. So slash content slash drive slash my drive slash tehri.png. If I call, so the function for reading the file is mpimg has a function called imread. Imread, it reads a PNG or just JPEG files. Now if you see the shape of this file, as we said that this is a RGB image. If we see the shape of this image, actually this says 3057 into 3852 by 3. So actually in this particular image there are 3 channels. So one first channel is R, G and B. So this is an image of 3057 pixels in rows and 3852 pixels in columns. So this way. Now suppose if you want to visualize this image, then the function you need to call plt.imshow. So plt.imshow, and you need to pass it an numpy array of 3 dimensions. So if you pass an numpy array of 3 dimensions to this plt function, so the function plt.imshow and pass it whatever we have passed to img. So and you can see you can visualize the image, right? Now if I just run this img, then you will be seeing it as an array. I will plus code img. If you see, now you can see that this is an numpy array of 3 dimensions. So any individual you can see from this. So you just need to remember, as of now there is a function called implot. So implot just plots your 3-dimensional array, right? Now suppose instead of visualizing all 3 bands together, suppose if you want to visualize a single band, so just by this array slicing we can fetch like maybe R band, G band or B band individually from that array. So like this, suppose if I'm interested in only a red band data, so by using these slices I am just fetching the red band from that data, and if I call red data dot shape, it is an array of 3057 by 3852, then I will call the same function plt.imshow and pass it my numpy array, 2-dimensional numpy array. Then you can see that this is a single band or grayscale image. Then it has some color map has been applied to it. Now suppose if you want to change the color map, because it's a single band image, and you suppose if you want to see this particular image instead of on this color map, you want to apply your own color map. Suppose if you want to see this image in black and white, or you want to apply a grayscale map, so then you can pass it to imshow function and second argument call cmap. Actually there are you can go through the documentation, there are many more color maps which you can apply for visualizing this particular image. So plt.im show your two-dimensional array and color map. So here, suppose if I want to attach a color map to this, actually the contrast of this image may not be very good anyway, but it is visible. So now, because you don't know what pixel values these colors represent, so suppose if you want to attach a color bar reference to that image also, then also can be attached. Like here, you can now with plt.im show, if you call the function plt.colorbar, so what it does, it attaches a color bar also to the visualization. Now here you can say that a color bar got attached. So all whites have the value 1, like these blacks part are maybe near 0 values. So this way you can attach a color bar to that image. Now suppose if you want to visualize all three bands together, so that also can be done. Like there is a function called plt.subplots. Plt.subplots creates subplots inside a inside a figure. Actually basic figure is the entire canvas in the terminology of matplotlib. Figure is the entire canvas, and that canvas you can subdivide into subplots. Now suppose if inside this entire image you want to visualize all three bands together but in different subplots, so there is a function called plt.subplot. So plt.subplot creates subplots inside our main canvas. So there it accepts three arguments, right? So it is saying like this entire 1 comma 3 means you break this entire canvas into one row and three columns, and out of that take the first one, right? So plt.subplot 131 takes as break the entire figure in three subparts with the one rows and column, and this is take the first one. So here we are taking the second one, and in the third part we are taking the third one, and on the first one we are plotting this zero red band. In the second we are asking to plot the G, and in the third we are asking it to plot the B. So like this you can visualize the images. Then you can change their color map, or suppose if you want to arrange them in one row and three columns, then you can specify it as 3, 1. Then you can see that it gets arranged into this 3 rows and 1 column. Right, and suppose if you want to change the size of this figure, like if you want to make its shape to be a bit lower than 5 by 3 by 4, 5 by 15, then fixed size, by calling the fixed size you can change the shape. So this way you can visualize the images using NumPy. Actually tomorrow onwards we will read the data finally georeferenced or geotiff images using a different library called GDAL. So this is just a quick summary of today's session. Those the takeaway for today's session is, first we discussed about the NumPy. So NumPy is the core or fundamental scientific library, that is all the entire Python data processing or data analysis ecosystem revolves around this NumPy library. So almost all of the libraries are based on this NumPy library only. So NumPy is an excellent library for handling numerical data. So it can handle n-dimensional data. So first we saw how do we create a one-dimensional array using np.array, and to that we pass the list. Then we saw how do we create two-dimensional arrays. Then there are functions for, like suppose if you want to create an array with some predefined values, maybe 1, 2, 1, zeros, or so there are functions, and you can copy the shape and types of data type of element also by using zeros, like, ones, like, and all. Then we saw there are different ways to index once we have created or put some data inside a NumPy array. Then using these indexes we can fetch back that data. For one-dimensional array we need just a single index, two-dimensional we need two indexes, for three-dimensional we need three-dimensional. Then we discussed like an RGB image is represented as a three-dimensional array in NumPy. Then we saw how do we visualize. So for visualization, we use the plot matplotlib. We need to remember just a single function, im show. So im show is for visualizing a two-dimensional or three-dimensional array. So to the IM show we can pass a three-dimensional or two-dimensional depending on what we want to plot. So your plt.im show. So here is the those results. Then inside a figure we can create subplots or arrange them in rows and columns. So you can read more about this before the next session. So with that we come to the end of today's session actually. So if you have any questions, you are welcome to post on the chat box. I will try to answer as much as I